Another lesson with Howie. Yes, you've got lots to go, just so you know. So hopefully you're not getting too sick of me already, and if you are, you probably won't be watching. So, anyways, we are already in week 2. We're going to be talking about atmosphere and weather today. But just so you guys know, I know you guys already know this, time is going to fly by. It already is. The first week's over and done with. So make sure you guys are keeping up with everything. But let's begin, shall we? I think we should. But before we begin, let's take a look at the weather forecast. So I'm speaking right now, and mind you, it's crazy weather outside. School is canceled for my kids tomorrow. So let's take a look at the weather of what else we have going on here, okay? All right. Check it out.
We had beautiful weather here for this weekend, mostly sunny skies and highs in the upper 80s. Overnight tonight, partly cloudy, mild, with those temperatures dropping down into the mid 70s. Now we've got some big changes here for the upcoming work week. Starting tomorrow, we're going to have a volcanic eruption right near Charlottesville, and it's going to make things rather toasty across the area. We're going to see lava spill out into central Virginia and make temperatures in Richmond at 350 degrees, Fredericksburg at 345, Charlottesville, the hot spot, at 400. Not as hot off towards the Tidewater. A little bit more comfortable with highs near 100 degrees. The reason why, we're going to have tidal waves moving in ahead of this. A global superstorm developing off towards the Atlantic Ocean. This thing is headed our way, but the key to the forecast, right before this thing makes landfall, it is going to be deflected by Godzilla. Now, a lot can change between now and then. We're looking at the latest data. We'll continue to bring you the very latest. I do want to encourage you, though, that if you ever do see a sleeping coyote, do not wake it. Bad idea. Okay, here's the forecast. Volcano 350 there for Monday. Global superstorm on Tuesday. We could see maybe about 200 inches of rainfall, wind gusts up to 1,000 miles an hour. Godzilla Wednesday, I'll be honest, I have no idea what's going to happen on that day. After that, though, how about this to finish off the work week? Low humidity, lots of sunshine, with highs in the upper 80s heading into next weekend.
There you have it. Your weather, right? So much to look forward to. Godzilla? Yeah. All right, so anyways, let's get going. You guys know I like a little goofiness in my lessons. Ha ha ha. So the Earth's atmosphere, the first thing we're going to talk about. So just a few little tidbits for you. So from the surface to 6,200 miles up is the atmosphere, okay? 6,200 miles, that's a lot. Like, yeah, that's a lot, okay? Straight up. Not like across the world, straight up, okay? The atmosphere is made of nitrogen, oxygen, argon, and many other little traces of other gases. Okay, but the big ones are nitrogen, oxygen. Argon is not quite as plentiful as oxygen and nitrogen. And obviously we need this atmosphere. So it's because of our atmosphere that we have life. So if you guys know anything about any other planets, if you guys love astronomy, you'll know that a lot of the other planets, they don't have an atmosphere, or their atmosphere is not conducive for life. So obviously our atmosphere is pretty stinking important, okay? And those things are made up of our atmosphere, nitrogen and oxygen. Obviously we need oxygen to breathe, but it's interesting that we can't have like 100% oxygen in our atmosphere. It's just at the right levels, okay? So it's kind of interesting. It's this perfect balance. So it's why we can have life that's sustaining. So there are layers of the atmosphere, and I kind of like some of these pictures. I'll go through both of them, but you have, Earth right here, and then you have the troposphere. So down here you can see it too. I'm going to kind of go through both of them at the same time. The troposphere is basically what we live in, okay? You have life here, you've got trees and mountains in this one. You've got this nice little hot air balloon, and pretty much airplanes kind of are usually soaring right on the edge of the troposphere, okay? Sometimes they'll get above the or into the stratosphere, but most of the time they're right on the edge of the troposphere, okay? And then you have the stratosphere right above there, okay? Stratosphere, basically you have thin clouds, you have Mount Everest can even peek up into the very, very beginnings of the stratosphere. Then the mesosphere, okay, meteors, and then the thermosphere. That's where you have our satellites that are floating around, and this is I think talking about the aurora borealis, so the northern lights and such that happens up in the thermosphere. So those are the layers of the atmosphere, and so much of it, this actually gives lots of detail. Okay, it talks about temperature, the temperature decreasing and increasing. So as you go up, typically it decreases, but the thermosphere, it actually will increase in temperature, which is kind of interesting. But it also has large fluctuations in temperature up in the thermosphere. So anyways, there's just a lot of details. I'm not going to go over all of those, but there's some great pictures that you can also see in your unit. Check those out because it's cool to see what goes on in the different layers of atmosphere and how important each one of those layers are, again, for sustaining our life on Earth. All right, so atmospheric pressure, okay? What that is the atmosphere exerts a pressure on all objects in all directions, okay? Think of it as we're on the Earth, okay? Let me go back just one little picture. Now, we're on this Earth here, right? We have all of this atmosphere above us. Don't you think that's kind of heavy? Yeah, well, there's a pressure, okay, and it's exerting it on us. So it's interesting that we don't really think about the air and, you know, the atmosphere itself having pressure and exerting pressure on us, but it does, okay? But there's some interesting things to know about, you know, what this atmospheric pressure is and what happens as certain things happen. So take, for instance, atmospheric pressure decreases as you increase in elevation. And think about it, as you go up higher, there's actually less atmosphere above you, but also there's less molecules, okay? So this picture is a great picture of kind of all the molecules in the atmosphere, and they start to kind of lessen as you go up. So you have a lot more, whatever, if it's oxygen, water molecules, nitrogen, all these are very condensed down here near sea level, okay? But as you start climbing up, maybe you want to climb up Mount Evans here, okay? The oxygen is obviously a lot more sparse. That's why people have to use oxygen when they're climbing. But with that, if there's a lot less oxygen and other molecules, then you have less air pressure. So basically, this is kind of a generic looking barometer. A barometer is what measures atmospheric pressure. And basically, the higher you go up in elevation, the less the atmosphere is going to exert force on this mercury right here. And so basically, this level of mercury will not rise very high as you go up in elevation. But as you go down and get closer to sea level, the atmosphere is exerting more pressure on here, and it's going to force it up through this tube, and it's going to raise higher. So you'll just see that there's a tendency for, you know, that always to happen, okay? So we use that barometer, we measure that atmospheric pressure. The interesting thing is, and this is just, I don't think it talks about this in your unit, my husband and I were big into, you know, mountain climbing. We love climbing 14ers. But whether, you know, meteorologists and even us that go and hike mountains use a barometer and use the atmospheric pressure to determine whether or not there could be weather coming in as well. So that's why we talk about atmospheric pressure as well as weather kind of combined, because a change in the atmospheric pressure could definitely mean that weather is coming in. And when you're hiking a 14er, you want to know if weather's coming in. You don't want to be on top of that peak when you have, you know, thunderstorms and such. All right, moving on. So wind. Wind is defined as the horizontal movement of air. As you can see, these lovely little weeds, or pampas grass, whatever they are moving in kind of this horizontal motion, not, you know, vertical. Okay, so it's a horizontal movement of the air of the Earth's atmosphere. The development of wind results from changes in air temperature, but also changes in air pressure. So if you have a change in air pressure and you also have kind of this temperature change, the winds are going to start to develop, okay? And then, I could go into this again in more detail. I need you guys to make sure you always are reading your unit because it's going to follow up with more details. But air always moves from areas of high pressure to areas of low pressure. I want you to think about, okay, maybe you're in a huge crowd or something, and maybe you're super claustrophobic, because even though if you're not claustrophobic, I can't say that I love being in this crowd where you can't even like see, you know, all you can do is see up. So basically, all of a sudden you're in this room full of people, and this door opens up, and everyone's like rushing to get out, okay, and get some, you know, fresh air. Someone might have super bad BO or something, whatever. That's exactly what diffusion is, and that's what happens with air pressure as well. That basically air is always going to move from high pressure, okay, so there's a lot of molecules and the pressure is, you know, great, so those molecules are moving really fast, to areas of low pressure where the molecules start to move a little bit slower. Okay, this comes into play when creating wind. When you have the movement of basically high pressure to low pressure, you're creating this movement of air, which is what we call wind, okay? So, anyways, that's a little FYI. Differences in air temperature cause differences in air pressure and ultimately the development of wind as well. So, when you have differences in air temperature, so you have cold air masses and warm air masses, and you have this warm air mass that's going to rise, and the cold air is going to rush in to fill where that kind of void is, then you also create difference in air pressure, and you cause this movement of air, which becomes wind. So the greater the differences in temperature and in pressure, the greater your winds are. Okay, so that's why if you have a windy day and you look out and you're like, what the heck, where's this coming from? Well, it all has to do with the change of air temperature and the changing of air pressure and how those kind of interact together. Okay. Now the Coriolis effect, there's not a lot to talk about with this other than the fact that our Earth spins makes it so that winds, and we have wind patterns. You guys have to know that there's these constant wind patterns. Depending on where you are, you have different, there's a Santa Ana winds, and all these different winds that you'll learn about more in high school when you take, I think, basic earth science and stuff. But ultimately, the Coriolis effect is just showing that you have different winds. So you notice that there's the southeast trade winds, the northeast trade winds, the prevailing westerlies down here. Basically, they're all going in a certain direction, okay? So they have this curve to it because of the Earth's rotation, okay? So that's really all I want you guys to know about the Coriolis effect. It has everything to do with just the rotation of the Earth, but there's these set winds that basically have these patterns. Okay, a little bit about weather fronts. So a warm front here forms when warm air mass pushes up and over a cold mass. Okay, and these actual points came just from your unit, so I'm just kind of reiterating these facts. As the air gets cooler, it releases water in the form of precipitation, and steady rain may result. Okay, but typically, okay, you have kind of stable air, you know, with a warm front. So basically, here it's showing this warm air advancing. Cold air is going to be kind of pushed up. Okay, so basically, warm air mass is going to push up. Up and over a cold air mass. So like I said, the air gets cooler, it may release water in the form of precipitation. Okay, so there's kind of the warm fronts. The cold fronts forms along the leading edge of a cold air mass advancing against a warm air mass. So you can see the cold front is like, all right, I'm gonna get you warm air, and it's gonna cause that warm air to be pushed up. This results in turbulence in the air and heavy precipitation. So when we think of a cold front, we're definitely thinking of colder weather, typically precipitation, oftentimes thunderstorms. Warm air mass can cause precipitation, but it's typically kind of a light, not a whole lot of change. So warm air masses are not always, but really for the most part, you have stable, warmer weather. With cold fronts, you typically have weather, and these are a lot of times. This is definitely, you see this a lot more in the summertime, especially in Colorado, because we see those thunderstorms in the summertime a lot, and it's because you have these cold fronts that basically push that warm air up, start to build those cumulonimbus clouds, which are those nice, pretty, puffy clouds. They build, and then you have thunderstorms. Okay, so there's your cold front. And then a stationary front forms when a cold and a warm air mass meet together. Neither has enough force to move each other, so it becomes stationary, where that cold air front and the warm air front kind of just join. Okay, it'll produce lots of clouds, but not much precipitation. So clouds will start to build, but not much comes out of that. Okay, so stationary front, kind of you know, nothing really is happening there. So here's just one more picture where you can kind of see the cold air mass. This is the cold front here. The cold air mass is moving here, causes that warm air mass to be pushed up, and you're going to have that heavy precipitation that basically is underneath there. It starts to build those huge clouds. Okay, where the warm front is going to basically move up over this cold air mass. Okay. And you might have some precipitation there, okay, but the warm air is advancing over that the cold air. And last but not least, so I just want you guys, again, just to be familiar with kind of what you see on the weather map. So when you watch the news, maybe with your parents, start to pay attention to what's going on here. All of these different things, and again, it talks about it in your lesson, but you have different things that you'll see on a weather map, these H's and the L's. So you have high pressure systems and low pressure systems, okay? And then you have all these different crazy little things that look like flags all across the United States, right? Well, they mean different things. You have cold fronts moving in that are typically these blue triangles, and the arrows are basically pointing in the direction that that cold front is moving. And then you see these warm air fronts, okay, where basically same thing, it's red, but it's little rounded half circles. And again, that's pointing in the direction in which that front is moving. You have a stationary front, okay, and then you have also other things that I won't go into, like the occluded front. But just make sure that you guys read through in your lesson and understand a little bit about what those weather maps are showing, because it's kind of interesting that when you can go watch the news and this isn't just this foreign picture, like, what the heck, I don't even know what any of that means, why are they showing this? But really, you can tell a lot about what's happening in a map just by what this is showing. That a cold air front is moving towards here, this warm air front is moving this way. If they do collide, there could be weather that starts to form in here. These high pressure systems, the low pressure systems, those really dictate a lot, because again, changing that atmospheric pressure can create weather itself, okay? So there you have a little bit on weather and atmosphere. I hope that clarifies just a little bit for you guys. If not, you know that I'll always go over anything in class. So that's it. We'll see you soon.